Okay, so in the rewind, you went over a couple problems based on what we learned yesterday, which is how to solve a system of equations by graphing. Just as a couple reminders, a system of equations, remember, is two equations that contain the same variables and they potentially have a solution. And that solution would be something that works for both or every instance of the variable. So for example, in number 1 and 2, the question says tell whether the ordered pair is a solution of the given system. In our ordered pair, remember we know that this is always the x and this is always the y. So we're trying to figure out if this x value 3 and this y value 1 would work if you plug them into both equations. And if it is a system, then it will work for both of the equations, not just one of them. All right, so hopefully in the rewind you found that yes, number 1 was a solution and no, number 2 was not. When you're graphing these onto coordinate planes, or if you're finding a solution by graphing, what you've got to do first is graph them, and then you're looking for the spot where they intersect. If they don't intersect, there's no solution. All right, if they do intersect, whatever the point is that they intersect at, that's the solution to the system of equations. So I'm just going to do number 3, and then if you did not get that for number 3, take a look at what we do right now and apply that to try number 4 again. All right, so for the first one, let's call this A, equation A. When I graph equation A, luckily these are already in slope-intercept form, which makes it pretty simple to graph because I've got a y-intercept of +4, so I go up to 1, 2, 3, 4, and I plot my y-intercept. And my imaginary slope right here is 1 over 1, because if there's nothing in front of x, you assume that it's 1 over 1. So that means I go up 1 over 1, up 1 over 1. Since I'm already out of space, I'm going to go down a couple. I'm going to go backwards to do a couple more points just so I have a lot of points on this line. So instead of going up 1 over 1, I can go down 1 over to the left 1. All right, and there's that line. All right, so we say there's A. Now here's B. B is y equals negative 2x plus 1. So my y-intercept is 1. And my slope is negative 2 over 1, which means I'm going to go down 2 over 1. So down 2 over 1. The problem is if I keep going down, which I can do, I'm never going to get to the line. So instead of going down 2 over 1, I'm going to go up 2, left 1. And then I find up 2, left 1, that my intersection point is right here. And I'm going to highlight that in blue. There's your intersection point. Therefore, the solution to this system of equations is negative 1, because that's the x-coordinate, positive 3. All right, negative 1, positive 3. So again, if that wasn't what you got, or you weren't sure how we did that, make sure you plan on coming and checking with me during office hours so that we can go over that, because that is the rewind from what we did yesterday. All right, what we're going to talk about today is another way to solve systems of equations called substitution. And solving by substitution means exactly what you would think it means. Substitute means to plug in. So you guys in algebra have been plugging in for years and years, right? When you look at this equation right here, it says x equals 4. And you have an algebraic expression right here, 3x plus 14. If x equals 4, what does it mean to substitute? Well, all that means is to take that 4 and plug it in wherever you see x. So take a look at the expression down here. 3, instead of writing x, we plug in that 4. And since they're right next to each other, that means we're going to multiply. So I wrote that in parentheses because that's just another way of writing multiplication. So we've got 3 times 4 plus 14. 3 times 4 simplifies to 12. 12 plus 14 equals 26. So to substitute just means to evaluate it using a given number or a given value for that variable. All right, when we're doing that with systems of equations, how can we use this? Well, we use it the same way. Think back to what we talked about yesterday. We cannot solve a system like this as it stands because it's got too many variables in it. I can't solve an equation if it's got multiple variables in it. So what I need to do is get rid of one of the variables. And one way to do that is to substitute. Because take a look at this. Let's call this equation number 1 and this equation number 2. In equation number 1, we have y equals 2x plus 5. That means wherever you see a y, instead of writing y, you could write 2x plus 5. So I can use that in equation number 2. I've got a variable isolated, so all I have to do is take this and plug it in for y. Now what's that going to look like? So that's going to look like this. 2x, I still have 2x plus 3, but instead of writing y, I'm going to write 2x plus 5. However, since I have to write all that, 2x plus 5, I can't just slap it in there. I have to put it in there inside parentheses because it's its own expression. 2x plus 5 equals 31. And now I've only got one variable. I've got an x here and an x here. But I can deal with that because I can combine like terms, I can simplify. We all know how to do this. So let's take a look now at this equation. I'm going to call this equation number 3. All right? And let's see what we can do. So the first thing I need to do is simplify by distributing this 3. And I end up with, still got that 2x, plus 6x, plus 15 equals 31. All right, now I'm going to combine like terms, and I get 8x plus 15 equals 31. Now I need to get x by itself, so I subtract 15, and I get 8x equals 16. So then I divide by 8, and I end up with x equals 2. I'm almost done now because I've got x equals 2, so now just to figure out y, all I have to do is plug it back in. So if x equals 2, I'm going to go back up to equation number 1 right here, and I'm going to say y equals 2 times 2 plus 5. 2 times 2 is 4. 4 plus 5 is 9, so y must equal 9. Therefore, my solution is x equals 2, y equals 9, or you can just write it as an ordered pair, 2, 9. Okay, so 2, 9 is the solution to that system of equations, which means if I plug in 2 for x and y, I plug in 9 for y, it will work in both of those equations. Just to verify, let's plug that into equation number 2. 2 times 2 plus 3 times 9 equals 31. 2 times 2 is 4. 3 times 9 is 27. 27 plus 4 equals 31. That checks. There's our solution to our system of equations. So what you guys have right here are 5 steps for everything that we just did. And I know it looks like a lot. These system of equations problems are definitely not easy. But that's why we're going through and learning several different ways to do them. So yesterday we did graphing. If you're somebody who graphs really easily and likes to graph, always solve them that way. If you're somebody who is really good at manipulating expressions and moving around variables, then substitution might be the way you want to do it. Okay? Something that's extremely key is this step 1. Which is isolate a variable in one equation if needed. And we'll look at that in a minute. Okay? So there was a lot going on there. I hope that you're writing this down. All right? I will post this video. You guys can look at this video back again later. But there's a lot going on here, so make sure you're taking notes carefully. All right, so this is just all the work that we just did on a separate slide so that you don't have, so if you didn't copy it down correctly, you have all that answered out for you. All right, so our solution to that was 2, 9. Okay, now I want you guys to try it. So I want you to try this equation, or I want you to try solving the systems of equation using substitution. So for example, in my equation number 1, I know that y equals 2x. Which means instead of writing y in equation number 2, I can write 2x. So I take out the y and plug in 2x. So my new equation, equation number 3, says 2x equals x plus 5. All right, 2x equals x plus 5. Now what? I need to get rid of the x's on both sides, right? I can't have them on both sides, so I need to move them. So I'm going to move this one, and I'm going to say minus x minus x. What number is in front of here? I don't see one. Yeah, it's an imaginary 1, right? So minus 1x all over here. This goes away, and I'm left with 5 equals 1x, or just x equals 5. All right? And then the last thing you have to do is figure out your y, so you just plug it in. You can plug it into either equation, whichever one is easier for you. I think number 1 is fine, so I'm going to plug it into that. Y equals 2 times 5, so y must equal 10. Therefore, my solution is 5, 10. And I want to double check that that works, so I'm going to plug that back into equation number 2, because we already used equation number 1 to see if that worked. So I'm going to plug it into equation number 2. So number 2 would be 10 equals 5 plus 5. Is that true? Yes, because 10 equals 10. Therefore, that solution worked. Okay, now, what I said a minute ago is that, and this is really key, sometimes you have to isolate a variable. So sometimes you're going to be left with problems where you don't have a variable by itself. So let's take a look at an example problem where you don't have a variable by itself. And I don't have a blank slide for you guys, but just find some space on your slides because you're going to want to copy this down. All right, so let's say, for example, I have this. 2x minus y equals 8, and 3x plus 2y equals 12. Okay, we might end up with decimal numbers here, but that's okay. All right, so now looking at these two equations, my system of equations, we're going to call this one 1, we're going to call this one 2. I don't have anything that I can sub in right away because I don't have a variable isolated. So that means that I need to get a variable alone. Isolate means to get a variable by itself. So looking at this equation, this set of equations, I'm going to look to equation number 1, and I'm going to isolate y. Does anybody know, or can anybody guess why I'm isolating y? Why is y the one that I'm choosing to isolate? Okay, hopefully you're noticing that y is the only variable, this one right here, is the only variable that doesn't have a coefficient, doesn't have a number in front of it. That tends to be the one that you want to isolate because that's the one that's easiest to get the variable by itself. So I'm going to write that down here, 1a is 2x minus y equals 8. And I want to get y alone, so I'm going to add y to both sides. And I get 2x equals 8 plus y. I can't put those together because they're not like terms. All right, and now I'm going to get rid of the 8 minus 8. I can't put these together either because they're not like terms, so I say 2x minus 8 equals y. And now I've got y by itself. And the reason you have to do that when you're substituting is because you cannot plug into something unless you have that variable by itself. So I can't plug this in for y if y is not alone right here. So the first thing I had to do was get y by itself. So this is going to be equation 1a because it's like equation number 1, but a little bit different. All right, so we just manipulated it to get y by itself. Now, I'm going to plug this in to equation number 2. Instead of writing y, I'm going to write 2x minus 8. But again, remember, when I put it in, I have to put it in what? I hope you're all shouting out parentheses right now. So I have to put it in parentheses, all right? So this is my equation number 3 because this is where I'm plugging in. So I've got 3x plus 2 parentheses 2x minus 8 equals 12. All right, now I'm going to distribute the 2, and I've got 3x plus 4x minus 16 equals 12. 3x plus 4x gives me 7x. I'm going to add 16 to both sides, and I get 7x equals 28. And I'm going to divide by 7, and I got x equals 4. Look at that, it was a whole number. We lucked out there because I made those up and I wasn't sure it was going to be a whole number, but it was. All right, so x equals 4. I'm almost done. I know you guys are sitting there thinking, oh my gosh, this is so much work. And yes, it is a ton of work, but you guys can definitely do this. I know that you guys are able to put your minds to something and get the problem right, so I know that you guys are able to persist through this, okay? So last step, plug this back in right here. Plug it back in and find out what y is. Doesn't matter which equation, I'm going to plug it back into number 2 because number 2 has all positive numbers and I like positive numbers. All right, so I'm going to plug in x equals 4 right here, and in my equation I put 3 times 4 plus 2y equals 12. 3 times 4 is 12, minus 12 minus 12, 2y equals 0. So divide by 2, y must equal 0. Okay, and my solution then is 4, 0. And just to double check, I'm going to plug that back into my top one, and I'm going to make sure that works in equation number 1 as well. So 2 times 4 minus 0 equals 8. 2 times 4 is 8, minus 0 equals 8, so that works because that's correct. All right, so again, a lot of work, but I know that you guys can do it. So go ahead up to your boards and work on these practice problems. There are only 6 of them, but a lot of them require a lot of steps, all right? So you have plenty of time to work on all of these. Please work together on them, use each other for help, and then if you need to go back and rewatch any of the previous parts of the video, just let the sub know and you can go back and watch those parts, okay? All right, now that you're finished with the practice, go ahead and get started on the exit ticket. You're doing those independently at your seats. There should not be any talking. This is your chance to show me what you know, not what your neighbor knows. All right, so go ahead and do these 4 problems. Just do them on the slides and then turn the slides into the substitute and they will get those to me and I will have them back for you on Monday. I hope you guys have a great weekend and I will see you Monday.